Good morning, students. Now we discuss about Kohlrausch law. Before that, we just know one point regarding equivalent conductance and concentration. In previous video, I told you already the relation between equivalent conductance and concentration is inversely relation, and similarly the relation between molar conductance and concentration also inversely relation. Here one point is there, that is, in case of strong electrolytes, we get the graph like this. That means the line is like this. That means here slightly decreases, but in case of weak electrolyte gradually decreases. Molar conductance or equivalent conductance gradually decreases with concentration. We should discuss these points why. Before that, we just know what is strong electrolyte, what is weak electrolyte. In previous video I already discussed about the definitions of these two. Strong electrolyte means it is completely dissociated. Weak electrolyte means it is partially dissociated. So when we add water to weak electrolyte, that means on dilution means addition of water. If we add more amount of water, then we get more number of ions. But in this case, if we add water or not, here number of ions completely dissociated already. So if you add water, there will be no use in this case. But here if you add more amount of water, then number of ions increases. If number of ions increases, automatically concentration decreases. That means concentration means moles per liter decreases. That is why equivalent conductance gradually, or equivalent conductance or molar conductance gradually decreases with concentration in case of weak electrolyte. That is the point. And next, here one more point is there. Dilution means addition of water. Infinite dilution means, that means we add water number of times. If we add water, automatically concentration decreases. If you add that water more times, at one stage you get zero concentration. That zero concentration is nothing but infinite dilution. Dilution means addition of water. Infinite dilution means we add water more number of times, infinite times. At that stage, concentration is zero. That is why this is called infinite dilution or zero concentration. Both are same words, infinite dilution or zero concentration. Here the point is the equivalent conductance or molar conductance. Equivalent conductance or molar conductance of weak electrolyte at infinite dilution can be calculated by using Kohlrausch law. So now we discuss what is Kohlrausch law. So here the statement is the molar conductance of weak electrolyte at infinite dilution or zero concentration is equal to sum of their individual ions. That means if we get sum of their individual ions, then automatically we get molar conductance or equivalent conductance of weak electrolyte at infinite dilution or zero concentration. I just repeat once again. If we get equivalent conductance of or molar conductance of ions, not electrolyte, ions at infinite dilutions or zero concentration, if you add those ions means that cation and anion, then we get molar conductance or equivalent conductance of weak electrolyte at infinite dilution or zero concentration. If you see the example, then you get idea. So these are the examples. Lambda naught m CH3COH. CH3COH, this is acetic acid. We know that this is weak acid, nothing but weak electrolyte. So how can we calculate the weak electrolyte of equivalent conductance at infinite dilution or zero concentration? This is zero means zero concentration. Lambda m means molar conductance. So now we have to find the molar conductance of this acetic acid at zero concentration. How? By using this expression. That means if we get these ions at these concentration, then if we add these two ions, automatically we get this value. Similarly in this case also, NH4OH, this is called ammonium hydroxide. This is also weak base, nothing but weak electrolyte. In this case also we get like this. So based on this one, some numericals are there. Now we discuss those numericals. First one, calculate lambda naught m. Lambda naught m means molar conductance, zero means zero concentration. Sometimes here infinity will be mentioned. Sometimes infinity is there. In such cases also we should think same. So both are same, lambda naught m or lambda infinity m, both are same. So here we should find molar conductance of CH3COOH at zero concentration or infinite dilution by using these three factors. They are these three substances. They are sodium acetate, HCl and NaCl. So you have to find this one by using these three. That means ultimately, finally we have to get lambda naught m CH3COO minus and plus lambda naught m H plus. That means we have to get those ions by using these three compounds. Now I discuss how we get those two ions by using these three compounds. I will show you now. See, which are given CH3COONA, next one HCl, next one NaCl. By using these three we have to get CH3COO minus and H plus at infinite dilution or zero concentration. See, suppose if you add CH3COONA plus HCl, if you add these two and subtract this one from these two, that means minus here, minus NaCl, then you get CH3COO. You just split these two, this one, that means CH3COO minus plus Na plus. Here HCl becomes H plus plus Cl minus. There minus NaCl means minus Na plus minus Cl minus. Here plus Na plus minus Na plus, both will become cancelled. Here also plus H plus, plus Cl minus minus Cl minus. These two also become cancelled. Then finally we get CH3COO minus plus H plus. While writing this one, before you should mention like this, lambda m naught, or you can mention here infinity. Here also lambda m naught, like this. So this is the way to write the answer. One more example like this. That is, we have to calculate lambda naught m MgOH twice, that is magnesium hydroxide, by using these three. That is MgCl2 NaOH plus NaCl. That means by using these three substances we have to find the molar conductance of MgOH twice. That means we have to find lambda naught m Mg plus 2 into 2. Here OH twice means 2 into lambda naught m OH minus by using these three. So first you add these two and subtract this one from these two. Then automatically we will get like this. So that is the way to calculate the equivalent conductance or molar conductance of weak electrolytes at infinite dilution or zero concentration. Sometimes the question may be like this. See, lambda naught m for NaCl, HCl and CH3CON, both are here, values are given for respective compounds. Then we have to find lambda naught m for CH3COOH. So here we have to find lambda naught m for CH3COOH by using these three. So first you should take this one, lambda naught m CH3COONA plus lambda naught m HCl. But in required compound, this is required compound. In that compound, Na is not there. That's why we should remove NaCl part. So if you add these three, if you write like this, finally we get lambda naught m CH3COO minus and lambda naught m H plus. Automatically we will get the value of this one. Now no need to splitting these ions. You just substitute these values in these expressions. Lambda naught m CH3COONA, that means its value is 91. Lambda naught m HCl, that means its value is 425.9 and minus 126.4. Then finally we get the value. So these type of problems we face for 1 mark or 2 mark questions in CBSE level. So these are the models regarding Kohlrausch law. Next, two important formulas are there. They are degree of dissociation, that is represented by alpha. Already it is came in solutions chapter, but that is different. This is different. Here, degree of dissociation is the ratio of molar conductance. C means at a given concentration. Molar conductance at given concentration to molar conductance at zero concentration. Molar conductance at given concentration to molar conductance at zero concentration, ORR. Equivalent conductance at given concentration to equivalent conductance at zero concentration. Or here you can mention infinity. Both are same. At infinite dilution or zero concentration, both words are same. That is one formula. One more formula, that is degree dissociation constant of weak electrolyte, that is represented by K. K equal to C alpha square by 1 minus alpha, where alpha is degree of dissociation. That means if you calculate this value, before that we should calculate degree of dissociation, that is alpha. Here C is concentration. So based on this, one problem is there, that is the molar conductivity, that means lambda m of 0.025 m mole per liter. That means this is concentration, mole per liter, nothing but molarity. Methanoic acid is 46.1 Simon centimeter square mole in mass. That means this is molar conductivity of methanoic acid at this concentration. That means molar conductivity of methanoic acid at this concentration is this value. That is the meaning of that one. Calculate its degree of dissociation and dissociation constant. That means we have to find alpha and K value. Given lambda naught H plus is equal to, that means given lambda naught H plus and lambda naught HC moments both are given. So we have to find alpha and K value. To find alpha value, the formula is alpha equal to lambda mc by lambda m0. Already lambda mc is given. I told you already. The molar conductivity at this concentration of methanoic acid is this one. That means lambda c is given already. Now we have to find lambda naught m. That means equivalent conductance or molar conductance at zero concentration of methanoic acid. First we have to know what is the formula of methanoic acid. Methanoic acid formula is HCOOH. That means we have to find lambda naught m methanoic acid. So lambda naught m methanoic acid, we have to write like this: lambda naught m. Just now I told you already. Lambda naught m H plus lambda naught m HCOO minus. If you add these two ions, automatically you will get the value of this one. Already these values are given. If you substitute these two values in this expression, then you get lambda naught m HCOH. Already this value is given in question itself. So if you substitute those two values, you get alpha value. After finding alpha value, you can get the value of K value. K equal to C alpha square by 1 minus alpha. Already C is given. This is the C value. If you substitute all these values, you will get total value. So like that, we have to calculate the problems based on this concept. Electrolysis. The dissociation of electrolyte by the passage of electricity is called electrolysis. That means if you pass the electricity through electrolyte, then that electrolyte undergoes dissociation or decomposition or splitting. That is called electrolysis. Why it happens like that? When we pass electricity, that means we are giving electric energy to electrolyte, then that electrolyte absorbs that energy. Finally it undergoes dissociation. That process is called electrolysis. Here I want to discuss some points regarding electrolysis. That is, see, this is electrolytic cell. This is electrolyte. These are electrodes. These electrodes connected to battery. This whole process is called electrolysis. When it is called electrolysis, when electricity applied through battery, then that electricity passes through these electrodes. Electrodes nothing but cathode and anode. Cathode is negative charge electrode and anode is positive charge electrode. After passing electricity through electrodes to the electrolyte, then that electrolyte undergoes dissociation. After dissociation, ions will be formed. When these ions moves towards oppositely charged electrodes, then they undergo discharge. This whole process, then only this whole process is called electrolysis. So electrolysis contains electrolytic cell, electrolyte, electrodes passing electricity. For example, I take NaCl electrolyte. When electricity is passed through this electrolyte, then NaCl becomes Na plus plus Cl minus. This takes place by passing electricity. This step is called ionization step. That means ions are formed here. That is why this is called ionization step. After forming ions, these ions moves towards oppositely charged electrodes. That means this cation moves towards cathode and this anion moves towards anode. Cation moves towards cathode and anion moves towards anode. Because cation is positively charged electrode but cathode is negatively charged electrode. That is why cation moves towards cathode. Here anion is negatively charged ion but anode is positively charged electrode. That is why anions moves towards anodes. Next, one more point is there. At cathode, every time reduction takes place. At anode, every time oxidation takes place. These are important points. At cathode, reduction takes place. At anode, oxidation takes place. Next, one more point. When anions moves towards anode, then it loses electrons. Those electrons again moves towards anode. Sorry, I repeat once again. When anions moves towards anode, this is anode, then that anion loses electron. Those electrons again moves towards cathode. That means at cathode those electrons gained by cation. So here the point is the number of electrons lost by anion at anode is gained by cation at cathode. I repeat once again. The number of electrons lost by anion at anode is gained by cation at cathode. That means the number of electrons will be same at anode and cathode. This total process is called electrolysis. So electrolysis, electro means electricity, passing electricity. Lysis means decomposition. So when electricity is passed through electrolyte, then decomposition takes place. That whole process is called electrolysis. Here's the definitions for electrodes is the metals which are used to pass the electricity is called electrodes. Electrolytic cell means the device in which electrolysis is carried out is called electrolytic cell. Next, some more points are there. The nature of products depend on nature of electrodes and nature of electrolyte. That means if you take aqueous electrolyte or if you take molten electrolyte, then we will get different products. We will not get same products. That is depends on nature of electrolyte. And one more point, if you take different electrodes, then also we get different products. Next one. Now we have to discuss about types of electrodes. Types of electrodes. There are two electrodes, that is active electrodes and inert electrodes. Simply, active electrodes means if electrodes involves in chemical reaction, those are called active electrodes. If those electrodes are not involved in chemical reaction, those are called inert electrodes or are inactive electrodes. Why electrodes are involved in chemical reaction? Now we see why. If the metal rods are dipped in their own solution, then those metal rods act as active electrodes. For example, if you take zinc rod in ZnSO4 solution, zinc rod in ZnSO4, that means zinc is placed in one solution, then this zinc rod acts as active electrode. That means in such case zinc rod involves in chemical reaction instead of ZnSO4 electrolyte. That is the meaning of this one. Similarly, one more example. If copper dipped in CSO4 solution, that means this is electrolyte, then this copper electrode acts as active electrode. That means this electrode involves in chemical reaction. So if any electrode is dipped in their own solution, then that electrode acts as active electrode, otherwise it is act as inert electrode. Next, one more point. If active electrodes are taken in electrolysis, then those electrodes undergoes oxidation and reduction instead of electrolyte. We have told you already in this one. If active electrodes are taken in electrolysis, then those electrodes undergoes electrolysis instead of electrolyte. Next example, if CSO4 is electrolyzing, that means this is electrolyte using copper means copper electrode, then the reactions is like this. Because if copper is dipped in CSO4 solution, then copper undergoes oxidation and copper undergoes reduction. I told you already, at anode every time oxidation takes place. Oxidation means loss of electrons. At cathode always reduction takes place. Reduction means gaining of electrons. So if any electrode is dipped in one solution, then that electrode undergoes oxidation and reduction. That means that involves in chemical reaction instead of electrolyte. Next one. During this electrolysis, the size of anode becomes less and the size of cathode become large. Very good point. Here electrode involves in reaction. That means copper electrode involves in reaction. Then copper electrode becomes copper ions. That means that electrode involves in reaction. But in case of cathode, at cathode, their copper electrode is there, but these ions, Cu plus 2 ions moving towards cathode, and these ions deposited over cathode electrode. That means the size of cathode increases, but size of anode decreases. So this is very important point. During this type of electrolysis, the size of anode reduces and the size of cathode becomes large. Next, inert electrode. Inert means inactive electrode. If different electrodes are placed in different electrolyte solution, those act as inert electrodes. If you understand the definition, the opposite definition of that one becomes this one. If zinc rod is dipped in CSO4 solution, then zinc acts as inert electrode. Similarly, if copper dipped in ZnSO4 solution, then copper acts as inert electrode. So we can say so many examples. If platinum electrode is dipped in aqueous NaCl solution, then the platinum rod acts as inert electrode. Next one. If inert electrodes are used in electrolysis, then electrolyte undergoes oxidation and reduction. But in case of active electrodes, electrodes undergoes oxidation and reduction. But here electrolyte undergoes reduction and oxidation in case of inert electrodes. For example, molten NaCl. Molten means fused state. Molten NaCl undergoes electrolysis using platinum electrode. Then the reactions takes place like this. NaCl, Na plus Cl minus. This Cl minus is anion, so it moves towards anode. Finally, it loses electron. The electron gained by cation at cathode, so it becomes sodium and Cl2. So this is the electrolysis process. There are some more points regarding this one. That is aqueous state. Aqueous state means if any substance takes in water, that substance is considered as aqueous substance or aqueous state. If an aqueous electrolyte is taken, these are very important points. If these are totally competitive points. Please remember carefully. Please note them carefully. If aqueous electrolyte is taken in such cases, if cation belongs to either 1A group, 2A group and aluminum. That means if cation belongs to either 1A group or 2A group, or that cation is aluminum, then water undergoes reduction at cathode, because the SRP, here new point has come, that is SRP, that means standard reduction potential. Those values, those are experiment values, those are already present in our textbook. You can find those values. So the point is, in such cases water undergoes reduction because the SRP of water is more than that 1A group, 2A group and aluminum ions. So the reaction is like this. So this type of reaction takes place at cathode. So I repeat once again. If aqueous NaCl, suppose aqueous NaCl, here Na plus is cation and Cl minus is anion. So this Na plus ion belongs to 1A group ion. In such cases, these ions never undergoes cathode. Instead of these ions, water undergoes cathode. Water moves towards cathode. Why? Because the SRP of water is more than these ions. SRP means standard reduction potential values. So every electrolysis process is based on SRP values. That means if SRP is more, suppose if I take two ions A and B, if suppose B is having more SRP value than A, then that B moves towards cathode than A. So here the point is, if any ion having more SRP, that ion is readily moves towards cathode to undergo reduction. And one more point, if any ion having more SOP means standard oxidation potential, then that ion is readily moves towards anode. So if any ion is having more SRP value, then that ion is readily moves towards cathode to undergo reduction. If any ion is having more SOP value, then that ion is readily moves towards anode to undergo oxidation. So here you no need to remember the SRP values and SOP values. You have to remember some values, not all the values. It is very difficult to remember all the values. I tell you later which values you have to remember. So the point here is, if aqueous electrolyte is taken in such cases, if cation belongs to either 1A group or 2A group and aluminum, in such cases water undergoes reduction at cathode, because the SRP of water is more than 1A, 2A and aluminum. So this type of reaction takes place at cathode. This part is regarding cation. This part is regarding anion. If aqueous electrolyte is taken, in such cases, if anion belongs to oxoanion, here you have to know one more point. Oxoanion, Cl minus, Br minus, I minus, all these are anions because they are having negative charges. OH minus, SO4 minus 2, PO4 minus 3. These are also anions because these are also having negative charges. So what is oxoanion? If anion contain oxygen, those are called oxoanion. These are oxoanions, but these are not oxoanions because they don't contain oxygen. So here the point is, in aqueous electrolyte, if anion belongs to oxoanion, in such cases water here also again same point, water undergoes oxidation instead of these ions, because water having more SOP, that nothing but standard oxidation potential. If cation belongs to, simple point here, if cation belongs to either 1A, 2A or aluminum, in such case water undergoes reduction instead of those ions. If anion belongs to either oxoanion, Then in such cases also water undergoes oxidation because the SOP of water is more than these ions. Then this type of reaction takes place at and you have to remember these equations. That means you have to practice the equation, then only you can understand the equation. Here one more equation also takes place at anode, that is not one more, either this equation or this equation. 2OH minus gives rise to H2O plus half O2 plus 2 electrons. Either this, you can write either this equation or this equation at a anode. Here only one equation is there. There is no other equation here. Here you can write either this one or this one at anode. Next, examples. These examples are also very important. You face these type of examples in competitive level or in CBSE level. Example, I take fused NaCl. Fused NaCl means liquid NaCl. Nothing but that NaCl contains Na plus ion and Cl minus ion only. Here the electrodes are inert electrodes. That means those electrons never participate in chemical reactions. So at cathode, in case of this NaCl, Na plus is cation, so that cation moves towards cathode, that cation gains electron, then Na plus become Na. Here at anode, Cl minus becomes half Cl2, or here you can write 2 Cl minus gives rise to Cl2 plus 2 electron. You can write like that also. So what type of question we face in the exam when fused NaCl undergoes electrolysis in the presence of platinum electrode or nickel electrode? Sometimes they may not mention inert electrodes. The question may be like this: if fused NaCl undergoes electrolysis in the presence of nickel electrode, that means that nickel electrode acts as inert electrode, then what type of reaction takes place at the anode, or what type of reaction takes place at the cathode? We may face such type of questions in competitive level or in CBSE level. Next, one more example. Aqueous NaCl. I took aqueous NaCl. Here both are, here also inert electrodes. That means those electrodes are not involving chemical reaction. So I told you just now. In case of aqueous, this one, here Na plus is cation. But that in aqueous, if you take aqueous compounds, in that cases, cation belongs to one A group, then water undergoes reduction. I told you already, water undergoes reduction. Here Cl minus, then here also Cl minus undergoes oxidation instead of water, because that Cl minus is not oxoanion. If suppose the anion is oxoanion, then in here also water undergoes oxidation. So these type of reactions takes place. Next, here see aqueous NaCl. Here also aqueous NaCl, here also aqueous NaCl. Then what is the difference? Here both are inert electrodes, here both are active electrodes. So you have to see the question carefully. So here I took active electrodes. If I take active electrodes, what happen at cathode and anode? Electrodes undergoes, the electrodes involves chemical reaction. So at cathode, Na plus electron gives rise to Na. Here Na gives rise to Na plus electron. Here no need to think about water, because both are active electrodes. If you take active electrode, that is aqueous NaCl, aqueous compound or molten compound, then those electrodes participates in chemical reaction. Next, one more example. Aqueous Na2SO4. Both are inert electrodes. If inert electrodes are given, then we have to see this one. Na2SO4. Again, Na sodium is 1A group element. In such cases, water undergoes reduction. Here SO4 minus 2 is anion. That means oxyanion. Here also water undergoes oxidation. That means in the cathode and anode, in both cases, water undergoes reduction and oxidation. Or here I told you one more equation, that is 2OH minus gives rise to H2O plus half O2 plus 2 electron. You can write that equation also. That will also correct. Next, aqueous CuSO4. Both are inert electrodes. CuSO4. This Cu is not belongs to 1A group. So definitely that Cu undergoes reduction. because that is cation. Next at anode, this is oxyanion. So if oxyanion is there, so water undergoes oxidation instead of oxygen, so you can write this equation or this equation. So this model is very important for competitive level. So this is all about electrolysis. Next topic, Faraday's laws of electrolysis. In this one, two laws are there. One is Faraday first law, second one is Faraday's second law. We have to discuss about those two. First one, Faraday first law. It says that its statement is the mass of substance is deposited or liberated or dissolved is directly proportional to quantity of electricity is passed through the electrolyte. That means if you want more amount of substance, you should apply more amount of electricity. That's all. That is the Faraday first law. If you need more marks, you should do more hard work. So getting marks is directly proportional to hard work. Like that, here also getting mass is directly proportional to quantity of electricity. So from this, the statement is M is proportional to Q, where M is mass of the substance deposited is directly proportional to Q. Q means quantity of electricity. If you remove proportionality, then you get one constant. Here that constant is E, small e. So this formula also can be expanded as follows. That is M is equal to small e into Q means quantity of electricity. Quantity of electricity is nothing but C into T, nothing but current into time. Here C is current, T is time. Here small e is electrochemical equivalent. Here this one again can be expanded as small e is equal to capital E by F. Here capital E is called chemical equivalent or equivalent weight. Both are same, chemical equivalent or equivalent weight. Small e is nothing but electrochemical equivalent. This is chemical equivalent. Now later we will discuss what is electrochemical equivalent and what is chemical equivalent. Next, F means Faraday. Faraday means 1 Faraday is equal to 96,500 coulombs. So this is the final formula, that is M is equal to, here E is chemical equivalent, that also can be expanded as A by Z. That means chemical equivalent or equivalent weight equal to atomic weight by valency. Already this formula came in class 11 periodic table chapter. So chemical equivalent or equivalent weight is equal to atomic weight by valence. Here Z is nothing but valency. So finally this is the formula regarding Faraday first law, that is small m is equal to capital A by ZF into C into T, where A is atomic weight of the substance, Z is valency, F is Faraday, C is current, T is time, M is mass of the substance deposited at a particular electrode. Next, here some points are there regarding this one, that is electrochemical equivalent and chemical equivalent. We should know the definitions of these two. Electrochemical equivalent, this is represented by small e. So electrochemical equivalent means the mass of substance is deposited when 1 coulomb of electricity is passed through the electrolyte. That means if you pass 1 coulomb of electricity through the electrolyte, then some amount of substance is deposited. That amount is called electrochemical equivalent. So the definition is the mass of substance is deposited when 1 coulomb of electricity is passed through the electrolyte is called electrochemical equivalent. Here chemical equivalent, this is represented by capital E. This is also called equivalent weight. Here the definition is the mass of substance is deposited when 1 Faraday of electricity is passed through the electrolyte. Here 1 coulomb of electricity. If you pass 1 coulomb of electricity through the electrolyte, then you get some amount of substance. That amount is called electrochemical equivalent. Here 1 Faraday of electricity, nothing but 1 Faraday is equal to 96,500 coulombs. If you pass that much amount of electricity, then also we get some more amount of substance compared to here. Then here that amount is called chemical equivalent or equivalent weight, that is represented by capital E. Here some points are there regarding this one, that is these are the ions. Suppose we are having Na plus ion, Mg plus 2 ion, Al plus 3 ion, Na plus ion. Suppose if I want 1 mole of Na, for that I should pass 1 Faraday, nothing but 1 Faraday is nothing but 96,500 coulombs. That is nothing but 1 mole of electron. That is nothing but 1 mole of electron. That means if you pass 1 mole of electrons to Na, 1 mole Na plus ion, then you get 1 mole sodium atom. 1 mole. So for Na plus ion, it needs 1 Faraday. Then you get 1 mole of Na plus. For example, as per reaction, you can write like this: Na plus electron gives rise to Na. This means if you pass 1 mole of electron, this is not 1 electron, 1 mole of electron, then you get 1 mole of sodium. Here 1 mole of electron is called 1 Faraday. That is equal to 96,500 coulombs. In second case, we are having Mg plus 2 ion. If you want 1 mole of Mg, then we need 2 Faradays because here plus 2 charge. So as per reaction, Mg plus 2 electron, then we get 1 mole of Mg. That means if you pass 2 Faradays of electricity or 2 moles of electrons or 2 into 96,500 coulombs, then you get 1 mole of Mg, not 2 moles of Mg, 1 mole of Mg. That is the meaning of this one. Here Al plus 3 is there. So if you want to get 1 mole of Al, it needs 3 Faradays, nothing but 3 moles of electrons, nothing but 3 into 96,500 coulombs. Then we get 1 mole of aluminum. Based on this, there are so many questions regarding competitive level. Suppose now we take these 3 ions: Na plus, Mg plus 2, Al plus 3. The question may be like this: if you pass equal amount of electricity, then in which case more amount of substance is formed? That is the question. The question is, we are having 3 ions. In these 3 ions, if you pass equal amount of electricity, in 3 cases we should pass equal amount, then in which case more amount of substance is formed? That is the question. So first we write like this: Na plus electron gives rise to Na. Next we write one more equation: Mg plus 2 electron gives rise to Mg. What is the meaning of this one? If you pass 1 Faraday, 1 mole of electron, nothing but 1 Faraday, then you get 1 mole of sodium atom. 1 mole of sodium atom weight is how much? 23 grams. Here just based on this one, you can write like this: if you pass 2 Faraday of electricity, then you get 1 mole of magnesium. See carefully, 1 mole of, not 2 moles. Then 1 mole of magnesium weight is how much? 24 grams. Write one more equation, that is Al plus 3 electron gives rise to Al. Here this meaning is what? If you pass 3 Faradays of electricity, then also you get 1 mole of Al. 1 mole of aluminum weight is how much? 27 grams. Here you pass 1 Faraday, here 2 Faradays, 3 Faradays. That means different you pass different Faradays or different moles of electrons or different electricity. The question is what? We should pass same amount of electricity, in which case more amount is formed. That is the question. Let us assume in all cases you pass 1 Faraday. Here already 1 Faraday is there. If for 2 Faradays the weight is 24 grams, then for 1 Faraday its weight is how much? 12 grams. Here for 1 Faraday the weight is how much? 27 by 3, nothing but 9 gram. So here 1 Faraday, 1 Faraday, 1 Faraday, and in all cases we take 1 Faraday, 1 Faraday, equal cases. So in which case more amount of substance is formed? In this case. So option is like this one. So these are the problems we face in CBSE, not CBSE level, no, competitive level. This is very important model. Next one, Faraday's second law. That is, here I take 2 electrolytic cell. This is 1 electrolytic cell. This is 1 more electrolytic cell. 2 electrolytic cell. If you take 2 electrolytic cell, automatically we should take 2 different electrolytes. This is 1 electrolyte. This is also 1 electrolyte. Both are not same. Both are different. electrodes, anode cathode, here also electrodes. Connect these two externally by battery. So the condition is in two electrolytic cells. For two electrolytic cells, we should pass same electricity. Then initially dissociation takes place. We discussed it already. Initially dissociation takes place. Then those ions, oppositely charged ions, moves towards oppositely charged electrode. Then amount of we get some amount of the substance of cation or anion at a particular electrode. That is explained by Faraday's first law. The second law says that if you take different electrolytic cells, if you pass same amount of electricity through different electrolytic cells, then the amount of the substances, that means the amount of the substance here and here, suppose here the amount of substance is, let us assume M1, here the amount of substance, let us assume M2, is equal to their equivalent weights. That is the meaning of that is the statement of the Faraday's second law. So I repeat once again, in Faraday's second law we should take different electrolytes, but we have to pass same amount of electricity through electrodes, then their amounts is equal to equivalent weights. That is the statement. So the statement is, if same quantity of electricity is passed through different electrolytes, then masses of the substance deposited is equal to their equivalent weights. That is M1 is to M2 is equal to E1 is to E2. So we can write this expression like this. That is M1 by M2 is equal to E1 by E2. So this is simple law. That is about Faraday's laws of electricity. So based on this one problem is there. That is, here a solution of copper sulfate is electrolyzed for 10 minutes. That means copper sulfate is electrolyte that undergo electrolysis for how much time? 10 minutes with a current of 1.5 amperes. That means 1.5 amperes electricity is passed through this solution for this much time. Then what is the mass of copper deposited at cathode? That means we have to find mass of copper. That means M. So in this case, in this question, current is given, time is given, we have to find M. So by using this formula we cannot calculate. So we have to follow Faraday's first law. So formula is what? M is equal to A by ZF into C into T. We have to find what? M. Why? Because in this question, what is the mass of copper deposited? That means we have to find M. Where A is atomic weight of copper. We know atomic weight is how much? 63.5. By valence is how much? 2. How can we say that here valence is 2? Because in CuSO4, Cu plus 2 and SO4 minus 2. That means plus 2 means that is the charge that can be considered as valence here to 2. F value we know that already 96,500 into current how much? 1.5 into 10 minutes means 10 into 60. That means time should be mentioned in seconds. So like that we can calculate any problem based on these two laws. So this is all about Faraday's laws of electrolysis.